Good morning, this is the Heat of Fusion of Ice Lab, TI Inspire Calculated Lab CBL. Today we are going to go over the calculations you need to do on your sheet to figure out what is the heat of fusion of ice. So we'll go to your handout. You guys should have your data table already set. Data table, your initial volume, your mass of water after it, so once it melted, your volume, your mass of ice, initial temperature, and lowest temperature. You also needed to figure out what the final temperature is, delta T. Delta T can be very easily figured out by the equation I just highlighted. Delta T is just T1 minus T2. So your initial temperature minus your lowest temperature, that's your delta T that will plug and chug into a calculation in a minute. For that calculation, you guys also need to have the final volume of mass to figure out the ice that was melted. For this, you have to find the energy needed to be released in 100 grams of liquid water as it cooled through your delta T. This is just a plug and chug calculation. The Q equals M times S times delta T. We can do this on the sheet right here. Q, which stands for heat. M, that stands for mass. S is a specific heat, which is a variable that's always going to be constant, times delta T. Now in your calculations on 24, you wanted to find the Q, the energy needed, to change the 100 grams of liquid water to be cooled through your delta T. So this is just a plug and chug. Here's Q, mass, 100 grams. That's given to you in number 24. Specific heat of water is a constant. It's 4.18 times delta T. Whatever that is for you, that's where you plug in. And then you're just going to calculate 100 grams times 4.18 times delta T. When you're Q, we're going to measure that in our units joules. And your answer needs to be in 3 sig figs. This will get you your answer on your student activity sheet number 24. Now we're going down to number 25, calculating the heat of fusion required to melt 1 gram of ice. We're doing joules, which we calculated over 1 gram of water. Number 25, once again, it's just plug and chug. 2.5 to 25. Take your previous answer, whatever your Q is. That goes here. Divide it by the mass of ice that melted. So that's going to be your calculation. Your initial volume minus your final volume, that's the mass of ice that you guys had melted, is going to end up with a number. Your label is joules per gram. Once again, this needs to be in 3 sig figs for all of my students. So this is telling us, this number that you calculated is telling us how much energy in joules it takes to melt 1 gram of ice. So if you put 1 gram of ice on your hand, how much is your hand putting out in joules or calories to melt that ice in your body? Your body has to do this all the time when you guys drink ice cold water. Anything that's below 98.6 degrees Fahrenheit for your body temperature, it's going to use this equation figure out how much heat is needed, aka how much calories are needed to heat up your food before you actually digest it. So that's question number 25 you have to answer. Now we're on to 26. Twenty-six leads us to, we're talking about the molar mass, as in molecular. We're going to take your answer, 26 joules per gram, the number you have, multiply it by how much water weighs. So you're going to use your periodic table. How much does one oxygen weigh? And how much does 2 hydrogens weigh? Add those up, multiply it by our number from above. Then you're going to take this whole number, because we want our final answer in kilojoules. Divide this whole answer by 1,000 joules per 1 joule up there. This will equal kilojoules per gram of molar mass. This also needs to be in 3 sig figs. So this is your number 26. 27 is percent error. Percent error is going to be how accurate you were or inaccurate you were. So the accepted value for this is 6.01 kilojoules per mole. You need to look in your notes and calculate using your VA, which means value accepted, your number here in kilojoules per mole. I'm sorry, this is not grams, it's actually moles, I apologize. And this would be your VE, as in your value experimental. So find the calculation or the formula to find percent error. And that's how close or far away you were from the actual answer. Finally, you have to do question 3 on page 4, which is explain your percent error value. I need you to give me 3 ways you could have possibly made mistakes in this lab, and human error cannot count. You can't say the calculator went wrong. You can't say you miscalculated something that was in the lab, some type of variable you were using to give you not accurate results. Thank you, and have a great day.